So today we're going to be discussing reciprocal trig functions, and then we'll also take you through a practice question on these trig functions. Reciprocal trig functions refer to cosecant x, secant x, and cotangent x, which can also be written as CSCx, SECx, and COTx. So these refer to 1 over sine x, 1 over cos x, and 1 over tan x. So what do these functions actually look like when they're drawn on graphs? First, let's take an example of f of x equals sine x, which means that when we draw 1 over f of x, we'll be drawing the graph of cosecant x. So the unit for HL analysis maths before the trig unit is the functions unit, where we learn how to draw functions such as f of x all squared, 1 over f of x, absolute f of x, etc. So obviously today we'll be using 1 over f of x, and the first step is to recognize that when f of x equals 0, so the x-intercepts, those locations will be asymptotes for 1 over f of x, since 1 over 0 is undefined. So the next step when drawing a 1 over f of x graph is to look at the end behavior of the graph. That is, what does 1 over f of x approach as f of x approaches certain values, such as 0 from the positive side in this instance? Well, we know that 1 over f of x is going to approach a very large number, because we know that 1 over a very, very small number, so as f of x approaches 0, like in our original graph, is going to essentially equal infinity. And likewise, we know that if f of x approaches 0 from the negative side, we know that 1 over a very, very small negative number is going to be essentially equal to negative infinity. So with this knowledge, we can then begin setting out the end behavior of our graph. So the final step for when you're drawing a 1 over f of x graph is to recognize that when f of x for the original function equals 1, your reciprocal function, so 1 over f of x, will also be 1, because obviously 1 over 1 equals 1. So just for every point on which f of x equals 1, we know that 1 over f of x will also be 1, so they'll touch. And likewise, when it's negative 1, then u will also be negative 1. So now, armed with all this knowledge about 1 over f of x, we can just connect the dots and follow all the clues to draw our new function. Now, when we take the reciprocal of cosine x, so when f of x equals cos x, our 1 over f of x will evidently be secant x. The process is almost the same, it's just a bit shifted. The first thing to do is, again, to see that our x-intercepts for cos x are the asymptotes for 1 over cos x, so for secant x. We lay out our end behavior, and then we can just begin drawing our graph of secant x, making sure to connect 1 over f of x to f of x whenever f of x equals 1 or negative 1. For the third trig function, we'll take you through things even faster. So when our original function f of x is equal to tan x, we know that our reciprocal function, so 1 over f of x, will then be cot x, so cotangent x. So like previously, our first step is again to lay out our asymptotes. Then we'll begin to investigate the end behavior, so we'll start to see that similar to f of x equals sine of x, when f of x approaches 0 from the positive side, 1 over f of x will approach infinity. On the other hand, as f of x approaches 0 from the negative side, 1 over f of x will approach negative infinity. We can therefore predict the graph's end behavior to be a bit like this, and then we can draw our graph of 1 over f of x, or cotangent x. So now that you've had an intro to the reciprocal trig functions and their graphs, I'm going to walk you through a practice problem.
Okay, so now we're doing a tougher question with trig functions with reciprocals, so cosec and sec. So the question is, given that cosec c is pi over 3 with this domain, and sine d is pi over 13 with this domain, find sec c minus d. So the first step is to rewrite sec into something more comfortable, which is equal to 1 over cos c minus d. And what we should be seeing right now is that we can also rewrite cos c minus d using identities. So we can write this as 1 over cos C cos D, change the sign, plus sine C sine D. So this question, when rewritten, is actually quite easy. We just need to find all of these four. And so some of them are given, like sine D, but then to find the rest of them, we just rearrange these. So if we start with cosec, we know that we can draw a triangle with a acute angle on the unit circle. So we're currently in here, so we're from 0 to 90 degrees. And so we say that cosec C is 5 over 3. So if we take SOHCAHTOA and reverse it, we know that sine is O over H, which means that 1 over sine, so cosec, is H over O, which would be 5 over 3. And so this must be 4 for Pythag. So that is C, which means that we know that cos of C would just be here, would be 4 over 5, so it's A over H in SOHCAHTOA. So we have cos C is 4 over 5, and the domain is all fine because for CAST, we know that everything is positive here. And if we now find everything else with C, we know that sine C is just 3 over 5, which is just cosec C flipped, obviously. Okay, and now to deal with the functions with D, and then if we draw another triangle, this time we're in this portion, so from 90 to 180. So if we draw this, and this is D, they give us sine D is 5 over 13. So we put O over H, and then again for Pythagorean numbers work really well for non-calc, so we have 12 here, which means that so we can fill in the given value of 5 over 13. And for cos D, now we just say that cos D is A over H, SOHCAHTOA, but we have to be careful because the CAST means that although sine is positive here, cosine is actually negative in this area of the unit circle, so we say that cos D is actually negative 12 over 13. And now the rest of it is pretty easy. We just say that this, so for the bottom, we say that it is these two multiplied, so it's negative 48 over 65 plus 15 over 65, and then 1 on the top, which is equal to 1 over negative 33 over 65, which is equal to negative 65 over